In this video, we're going to talk about topic 5.4. We're going to be using the first derivative test to determine relative or local extrema. We're going to answer the question, how do I find a relative extrema? And I can determine the relative extrema of a function using the first derivative test. So a function has a relative maximum, which is basically a hill. Remember, a max is a hill, okay? If f prime changes from positive to negative. Remember, we have to be able to prove whatever we do with calculus, okay? So we're going to be looking at the derivatives. A function has a relative minimum, meaning a valley, okay? If f prime changes from negative to positive. All right, and let's look at, to find the relative extrema, do its sign chart for f prime, that's the wrong prime of x. So start the same steps we did before. Find a critical number. Set up an interval from negative infinity to infinity in a table stopping at each critical number. Pick an x value in the intervals. Plug those into your most simplified f prime and write the sign. If it's positive, you write that it's increasing. If it's negative, you write that it's decreasing. If f changes from positive to negative, then it is a relative max. And if f changes from negative to positive, then it's a relative min. And we justify by saying a relative max because f prime changes from positive to negative, or their relative min because f prime changes from negative to positive there. So let's take a look at example 1. So the first thing I'm going to do is it says I have to find a relative max. So I am going to take a derivative, okay? Because they didn't give me a calculator. They didn't give me any of that information. So I have to do this by hand. So I'm going to start by just taking a derivative. So f prime of x equals 3x squared. This 2 is going to come in front. So these 2's would cancel. So minus 3x minus 18. To get critical points, set it equal to 0. I'm going to factor out a 3. So I get x squared minus x minus 6 equals 0. I would factor that using maybe a magic x, and I get x plus 2x minus 3 equals 0. I'm going to set all of my factors equal to 0 by zero product property. This one gives us nothing. This one says x equals negative 2, and this one says x equals positive 3. So those are my critical numbers for my sign chart. So I'm going to go ahead and set up my sign chart. This is the intervals. I drew that in kind of the wrong spot. So my intervals. So I'm going to go from negative infinity to my first critical number is negative 2. Draw my fence. My next critical number is 3. Draw the fence, goes to infinity. I know that now I pick x values, then I have to decide what's going on with f prime, and then I have to decide what's going on with f. All right, so a number that's between negative infinity and negative 2 would be, I would probably pick negative 10. Between negative 2 and 3, I would pick 0, and between 3 and infinity, I would probably pick 10. I am going to plug into my most simplified form of my derivative, which is this right here. We know that this first one's always positive. I have to decide on the other ones each time. So if I plug in a negative 10, I know this will go negative. I know that will be negative. So I've got a positive times a negative is negative times another negative is positive. Okay. Now let's look at 0. So when I put in a 0, I get a positive number here and a negative number here. So that means positive times positive is positive times a negative would be negative. Then we're going to plug in the positive 10. So when I plug in a positive 10, it's positive. When I plug in a positive 10 here, it's also positive. So positive times positive times positive is going to be positive. So what that means is that between negative infinity and 2, I am increasing because it's positive. Between 2 and 3, I am decreasing because it's negative. And between 3 and infinity, I am increasing because it's positive. So now the last layer of this, if I'm going from increasing to decreasing and then decreasing to increasing, that obviously makes a max. This obviously makes a min. So it was asking specifically for a maximum, so I have to write that out. I always justify my reasoning, even if it doesn't say to. So f has a relative max at x equals, so we can actually use this x value that's on the fence. So at x equals -2, because f prime changes from positive to negative. I really should be writing out the words at this value. All right, let's look at example 2. So we've got a slightly different function. I know the first thing I'm going to have to do is take a derivative, and they nicely snuck in a little product rule for us. Wasn't that nice? So we're going to take our derivative, f prime of x equals, I'm going to take the derivative of the red, which is 2x. I'm going to multiply that by the green, which is e to the x, the way it is. And then I'm going to keep the red original, which is x squared, and the derivative of the green would be e to the x. I'm going to set that equal to 0. It looks like I could factor out an x e to the x, which means that I've got a 2 left plus x, that is equal to 0. I'm going to use zero product property. Each one of these terms, there's 3 of factors this time that I'm going to set equal to 0. So x equals 0, e to the x equals 0, and 2 plus x equals 0. So that's actually one of our critical numbers. You're not going to get anything off of this, right? If I took the natural log of both sides, it doesn't make sense. So that one just doesn't get us a critical number. And then this is going to get us x equals -2. So I'm going to use these in my sign chart. I guess I'll stick my sign chart down below here. So my intervals go from -infinity to -2, -2 to 0, and 0 to infinity. I'm going to pick some x values. I'm going to substitute them into my derivative, and I'm going to look at what's going on with my original. So I am going to choose between -infinity and -2. I'm going to choose -10. Between -2 and 0, I'm going to pick -1, and between 1 and infinity, I'm going to pick 1. All right, so I'm going into my most simplified form of the derivative, which is this here. So let's see, I am plugging in a -10 to begin with, which is going to make this negative. Think about this right here. No matter what I do to that, it's always going to be positive, isn't it? Because if I put in a -10, e to the -10, it's going to bring it downstairs and make it positive. If I plug in e to the +10, it's going to be positive. So no matter what, this middle term is always positive. And then I put a -10 into here and I get negative. So a negative times a positive is negative, times a negative is going to be positive. All right, I'm going to put in a -1. So we're using orange for that. So I know that -1 will be negative here. We know everything is positive on the e. And 2 minus 1 is going to be a positive. So I get a negative times a positive is negative, times a positive is still negative. All right, and then we're going to put in a +1. So +1 would make this positive, always positive in the middle. 2 plus 1 is going to be a positive number. So positive times positive times positive is always positive. Wherever I am positive, I know that I am increasing. Wherever I am negative, I know I am decreasing. So I draw a picture of that. Increasing to decreasing, decreasing to increasing. So I know that this has to be a max because it's got a hill. This has to be a min because it's got a valley. And they were asking about relative min, so I write my concluding sentence about relative min. So f has a relative min And again, on the AP test, I would write out these actual words, not abbreviate. At x equals, that's happening at 0, because, remember, use your chart. F prime changes from decrease, or from, no, F prime changes, not F. So F prime changes from negative to positive at this point. So because F prime changes from negative to positive at this value, or at this point.